the next few months, periodically, we are going to take a little SOL timeout break, and we're going to try to review as much as we can for over the next few months between here and there. Headphones out, Christian. So this is one of the, last Friday was one of those days. We have some problems on the homework at 4 of these that we're going to go over here. So you should, in theory, be able to do all of these. So if you don't know how, or you think the book is wrong, or whatever your comments were, make sure you're writing them down and kind of processing and going through it as we do, okay? So number 1 here says find the roots of. Now these were all multiple choice questions. So we have options here when we have multiple choice questions. So I'm going to do it the long way and the short way to kind of remind us what we need to do. So in this particular problem, how many terms do you see? 4. I see 4. 1, 2, 3, 4. If it asks us to find the roots, that's the same thing as x-intercepts, solutions, zeros. They're all the same thing. So there's a couple of different ways I can do it. First thing I notice is if I factor it, can't I set each of those factors equal to 0 and find the solutions? You were here. I'm not sure. Did I see your homework? Okay, I need to see that before you go today. So I'm going to factor it first, and then I will check it on the graph as well. So we're going to do that both ways here. First 2 solutions, first 2 terms, second 2 terms. What's the GCF in the first 2? By the way, how did I know to group? 4 terms, okay? What's the GCF here? X to the 3rd. Take it out. I'm left with 2x plus 1. There has to be a 2x plus 1 here, or it won't factor. What can I take out from the other 2 terms? Not just 4x, but negative 4x, right? Because a negative and a negative. So I'm going to take out x cubed minus 4x as one of my factors, and then 2x plus 1 as the other one. Now, what do you notice about the first factor? What do you notice about it? Can I factor it again? I sure can. What can I take out of this one? An x. When I take out an x, I'm left with x squared minus 4. Continue to write the other one down. What do I notice about this factor? I can do it again. This is the difference of perfect squares. So completely factored, what does x squared minus 4 factor into? The difference of perfect squares would be x plus x minus, and what's the square root of 4? So 2. So x plus 2, x minus 2. If I set each of those factors equal to 0, how many solutions am I going to get? Do I expect 4? How do I know I should have 4 solutions? What tells me in the original problem that I have 4 solutions? Not 4 terms, the highest degree. Okay, so this number right here tells me how many solutions. Sometimes the solutions are imaginary or complex, but I don't have that here. I have all 4 real solutions. So x equals 0 is one of them. If I solve the second one, I get x equals negative 2. Oops. Another solution. I really wanted it to highlight. Why won't it do that? Oh well, whatever. Another solution. Over here, what's this solution going to be? Add 2 to both sides, x equals positive 2. And then over here, I'm going to subtract 1, divide by 2, negative 1/2 is the final solution. So if you look at your answer choices, do I see that as one of my solutions? I see, what answer choice would that be? That would be A. Okay, 2, negative 1/2 or negative 0.5, 0, and negative 2. Good. Now, that's one way to do it. Another way would simply be to graph the original function. So if I, bless you, if I plug this whole thing in, go to y equals, and plug it in, 2x to the 4th plus x to the 3rd minus 8x squared minus 4x, and I just zoom a standard window. We're going to see it cross the x-axis 4 times. I see, well, hopefully 0, 2, and negative 2, and then it looks like maybe at negative 1/2. Do you see it's like that W shape? Where that middle hump is in the W, it's hard to tell, but it does cross 2 different times. I could zoom in if I wanted to. I can go to my table and see that it crosses at 2, at 0, at negative 2. Why doesn't the negative 1/2 show up? Because the fractions don't show up, do they? Okay. So I could go back here. Sorry, go to my I could go ahead and calculate the intersection. I'm sorry, calculate the 0. And I could go to the left, to the right, hit enter, and negative 1/2 will show up that way. If it's multiple choice, couldn't I just plug in the answers and see which one worked? I could plug in a 0 for all of my x's, and I would get the 0 out. I could plug in a negative 2 in for x and get 0 out. I'll show you. I'm going to plug in a negative 2. 2, negative 2 to the 4th, plus 2, I'm sorry, negative 2, negative 2 to the 3rd, minus 8 times negative 2 squared, minus 4 times negative 2. If I just plug in my answers, what should I get as my, when I press enter on my calculator, what should come out? If it's truly a root, I should get 0, and I do. So I could do that also. That's one thing about math. There's like 5 different ways to come up with the answer. Find the one that works for you. Do you like the graph? Do you like the table? Do you like plugging it in? Do you like factoring it? I don't know. Okay? Any questions about number 1? You should be able to factor that from beginning to end. That will give you all of the integer zeros, the 0, the 2, the negative 2, but negative 1/2 will not show up. Okay, so you have to look at the graph and count how many times it crosses. Okay? Okay, what was another one you guys asked for? 8. So let's look at question 8. 8, by the way, is the one I graded for extra credit. So let me look at Moody's real quick so I can see if he has it before I grade it. No, you didn't. It's not H. You didn't finish because he's all the way to 16. Okay. All right, so let's go ahead and look at number 8. The answer, by the way, was G on number 8. So let's look at how or why we might have gotten it wrong. So we have, oh, completing the square. We didn't do that. But I can show you how to solve it. I never taught completing the square, so you don't have to worry about the process. But how would I solve that equation? Get it equal to 0. Very good. Because that's how I always said to do it. Is this factorable? If you actually look at your answer choices, don't they all have square roots in them? So that means that we're going to probably have to solve this with what method? Quadratic formula. So x equals negative b. B is already negative. Make it a positive. Plus or minus the square root of b squared minus 4ac all over 2a. Christian, how do I start to simplify that? What do I do first? Good. Anyone remember what that's called, by the way? What's underneath the square root? Begins with a D? The discriminant. Good. So that becomes 48. A positive 48 is the discriminant. Since my discriminant is a positive number, how many solutions are there? 2. 2 real solutions when your discriminant's positive. Okay? How do I simplify? By the way, that's not one of the answer choices. I could do that. If I forgot how to simplify this and it's a multiple choice question, what could I do here if I didn't know how to simplify? Go ahead and plug this in, get a decimal, and then go through each of your answer choices and see which one matches. Could I do that? That should work, right? So I'm going to do that, okay? And then I'll show you how to simplify longhand. So I'm going to go ahead and go to my fraction, alpha y equals 6. I'm going to do the positive. 6 plus the square root of 48 divided by 2. And I got that 6.464 decimal. Now I'm going to go through my answer choices. I'm going to figure out which one will work. I doubt it's the first two because they're negative 3's. So let's do 3 plus 2 radical 3. That's one of the answer choices. What do you notice? Exactly the same. So at this point, if it's multiple choice, I can stop because I know the answer is that one, which is G, I think. Yes. Okay? Now, if you wanted to go ahead and review how to simplify this longhand, simplifying the square root of 48, we're going to make a factor tree. Okay, April was right. What are two numbers that go into 48? 8 and 6. It doesn't really matter what you start with. Okay, 8 and 6. Keep going. Have to go until we get all prime numbers. I can't because I'd have to have a number in the front here because of that plus or minus. The 2 has to go into both of these things. So I can't divide the 3 yet. But I'm going to eventually. Okay? 8. What numbers go into 8? 2 and 4. How about 6? Okay? Keep going because the 4 is not prime. I'm just going to bring them all down. And I'm looking for pairs. So what? And then 3 stays underneath the radical. So what actually does this simplify to? What number comes out? 4. Good. 2 times 2. Now what we're going to do, Shamar, is divide all these by 2. I can't divide underneath the radical, but when I bring a number out, then I can. Okay? Do they all divide by 2? Yes. 3 plus or minus 2 radical 3, which is what I typed in. And I got that to be my answer. It was a long night. The book was wrong. Apparently it wasn't. We were just tired. Feel better now, though? A little bit? You want to take a test? Well, we already took a test on this. Again? I don't know that you want to. SOL's coming up. No. No. We already did that. We got to do new stuff now. All right, let's do number 9. Oh yeah, well, I've done your quarter tests. Yeah, next flex we're going to look at all those and put them in your folders, which for us won't be until, Lord, I don't know, with the snow next week, spring break, who knows, right? I don't know. Next couple of weeks we'll look at it. Number 9, okay? It says solve. This is the same type of problem, folks. I'm not going to do number 9 because it's the same exact thing. But here's the problem. This one has an I in it. How do I solve that? The I's mean the answer. Well, if I don't have a linear term, can't I just do this and then take the square root of both sides? If you don't have just a plain old x, I can do that. Now, the square root of negative 196 over 7. Okay, that looks kind of rough. How do I simplify that? What does the negative underneath the square root tell me? That's where your I. If it's an even root, not a cube root, not a fifth root, but it's even. This is the root is 2, isn't it? The index is 2. So since it's even, that negative will come out as an I. All right? And it is plus or minus. But how do I reduce the square root of 196 over 7? Well, I don't think it simplifies. I'll just check. But, oh, it does. Look at that. Can 28 be simplified? Let's do a factor tree. What numbers go into 28? Gabby, put your head up, honey. What two numbers go into 28? No. 2 and 14, that would work. 7 and 4 would work. 2's come out, 7 stays underneath. Plus or minus 2i radical 7. Hopefully that's one of the answers. if I was stuck and I didn't remember how to do this, and I went to my graph, will they show up? Let's try. If I plug in 7x squared, that's clear, 7x squared plus 196, and I graph it, what do you notice? I don't see nothing. Right? I could zoom out. Why don't I see anything? What's the y-intercept? 196. It's way up there. Do you agree? So even if I made my window go way up there, let's say go up to 250. Oh, I did the wrong one. Sorry. Thank you. I did x max. We don't want to do x max. We want to do y max. You can kind of see the graph way up there. Let me just go back to the standard. You can kind of see it up there. Way up there. Do you see it? Does it ever cross the x-axis? No. Does it make sense that I is in my answer? Sure. So looking at your answer choices, there are 2 that have I's and 2 that don't have I's. So what could you do? If you're stuck and you graph it and you look at your answer choices, what could I do with the 2 answers that don't have an I in it? Could I eliminate them? Could I cross them out? I know that's not an answer, right? So now what's my chance of guessing the question correctly? I got a 50-50 shot now, don't I? My odds are a lot better. So what I'm trying to teach you is that if you come across an answer you don't know how to solve, and it's multiple choice, try to eliminate answers that don't make sense. Then you have a better shot of getting it right. Okay? All right, last one before we get on to the new stuff. Which one did y'all want to look at? 16, the last one. We are, momentarily. All right, so let's look at 16. The total cost of x plus 2 markers is x cubed plus 5x squared plus 2x minus 8. What is the cost of each marker? Even if you didn't care about the word marker, what operation do you think we're going to do with these problems? If I look at my answer choices, the answer choices look like x squared plus 3x minus 4, x squared minus 3x minus 4, etc. What do you think I'm going to do if I have x plus 2 and I have this? And my answer choices all have degree 2. The highest power is 2. What do you think we should do to get my answer? Divide. Okay? Even if I don't know what the word marker means, I don't care about the word cost, but I look at the problem that's given to me, and I look at my answer choices, sometimes I can guess what operation they're trying to tell me to do. And here it's divide. So I'm going to remember, or try to, how to divide these things. You guys remember this stuff? Maria, what do I do here? Do you remember? It's been a while. Good. So she's trying to decide, and she's exactly right, this number times what will give me x cubed? And she came up with x squared. Do you agree with her? Is x squared times x, x to the third? I agree. But not only do we have to times it by this one, what do we have to multiply it by? This one too, 2x squared. What do you have to remember to do? Change your signs. 5 minus 2 is 3. Bring down the next one. Now what? Roll, now what? What's the next step? X times what is 3x squared? Not just plain 3, but 3x. Positive 3x, right? I'm going to take that and multiply times both of these things. 3x times x is 3x squared. 3x times 2 is 6x. What do I have to remember to do? Change my signs. This becomes negative 4x, negative 8. Angela, at this point, x times what is negative 4x? Negative 4. Let's see if it goes in. If it does, and my remainder should be what? 0. Let's hope it is. Negative 4 times x is negative 4x. Negative 4 times 2 is negative 8. Change my signs. My remainder is 0. So what's my answer? What answer am I choosing? This one. As remainder is 0, that's what's left. Now this is a long way. Do you guys remember synthetic division? Isn't that a quick way to do it? Do you remember how to do it? Do you want me to show you that at all? If you don't want to, don't look. Okay? But synthetic division is the other way to do it. Some number goes in the corner. I'm going to put my numbers across. I have 1, 5, 2, and negative 8. What number goes up here in the corner? Negative 2, because it's opposite of what that is. I bring down the first term. 1 times negative 2 is negative 2. Add them. Negative 6. Add them. Add them. That's the remainder. This becomes negative 4, 3x, x squared. Same thing. Because I go up by 1 every time. The last number is my remainder. Then it's a constant, x squared. If there was another one, it would be x cubed. Moody. Because x plus 2 is the factor, x equals negative 2. So we change in this method, we change the sign here. In the long division method, we had to change the signs every time. Okay? It's one or the other. They both work. All review. We've done it all up to this point. Okay? All right, new stuff. Brand new. Y'all, if you have graph paper, it's a good idea to get it out. We're going to get back to graphing. Okay? But if you don't, stand up, stretch for a minute, move your fingers, do something. So what we're going to do, I'm going to get to the graphing part in just a second. So you guys have straight edges and graph paper if you need it. That's fine. But we're going to talk a little bit first before we get to the actual graphing portion. Okay? We're going to be graphing a family of functions called reciprocal functions. Okay? So this is the word. And back at the beginning of the year when we did transformations, where we talked about a graph that might be shifted up, shifted down, left or right, flipped upside down. Remember we did our little dance, okay? Our happy dance. We're going to kind of come back to that a little bit, and we're going to look at this particular function, y equals 1 over x. And that is what we call the parent function, okay? Go ahead and take a minute and graph it on your graphing calculator. Plug it into the calculator. 1 divided by x. Christian, I've asked you at least twice to take those earphones out of your ear. Take them out. I don't want to see them. If you have your homework, I'll look for it, Taylor. So go ahead and graph it. Tell me what the graph looks like to you. Go to y equals 1 divided by x. Let's see what it looks like. So what I really liked is that Joseph went ahead and did 1 divided by x, not 1 times, 1 divided by x, and he actually graphed several other things as well. But let's start with the parent graph. I'm going to turn the light down a little bit so you can see up here on the smart board. But 1 divided by x, everyone should have this particular function. And if you remember, we did graph this before. It looked something along these lines. Okay? That's called the reciprocal function. Now, Joseph was playing around and said, well, what if I said 2 divided by x? How does that graph, how does that change? What if I said 3 divided by x? How does that change? So let's just see what would happen. It just kind of gets a little bit spread more away from the axis. What if I did, I don't know, 10 divided by x? What do you think is going to happen? It's going to get The middle part won't be as close to the origin. Let's keep looking. So it just kind of gets further away from the axes. It still has these guidelines of the x and y axis. It kind of still uses those as what we call, I call them guidelines. The formal word for those are called asymptotes. It doesn't mean asymptotes. It's A-S-M-P-T-O-T-E-S, asymptotes, okay? But they are guidelines for our graph. This particular function has what we call a vertical asymptote, which means that it doesn't ever touch this vertical line. It also has a horizontal asymptote, which means it gets close to that line but never touches it. So again, they're guidelines for our function. Okay? There we go. So let's decide here what an asymptote is. Oftentimes when we graph them on our own graph paper, we use a dotted line to represent an asymptote. By the way, this is how you spell it. Okay? A-S-Y-M-P-T-O-T-E-S. Asymptotes. The P is almost silent. Okay? It's actually not a part of the graph, but they're just simply guidelines for the graph. And again, there are two kinds, horizontal and vertical. Next class, we're going to look at how to find them when the functions are very odd and different looking. But for now, we know that in our basic reciprocal function, which is this function right here, or I can have a 2 up there, 3 up there, 4 up there, a 20 up there. Those are our guidelines. Basically, the x-axis and the y-axis acts as asymptotes. Okay? So, sorry, I'm looking at something here. So, what makes a graph, or what makes a function a reciprocal function? Where is the placement of the x? If I go back to my parent graph, where is the placement of the x? Where is it in the equation? In the denominator, okay? So what we're going to be looking for, and I'm just going to kind of look here, notice in our examples, the x is in the denominator. I'm going to kind of just highlight it here so you can see it. You don't have to write this down, just kind of watch. But the x is in the denominator. Notice it has a +1. Still a reciprocal function. What do you think that +1 does? Do you remember? Back from transformations, back when we did our happy dance? What does a +1 at the end of the equation do? Moves up 1. Good. Down here, notice that. The x is still in the denominator. Do you agree? What is that -2 going to do? 2 to the right. Remember, it's opposite of what you think when it's with the x? So it's 2 to the right. Very good. Down here, I have, again, a reciprocal function. What does that -8 do? Down 8. Good. We remember things. It's awesome. Notice the non-examples. Notice where the x is every time. Not in the denominator. So in order for it to be a reciprocal function with asymptotes, our x is going to have to be in the denominator. Okay? So let's look at, whoa, what just happened? Oh man, I hate when it does that. Let's look at this particular example down at the bottom here. Make it highlighter. Complete each question. We want to make it a reciprocal function. So where would, these are like my blanks, where would the 3x have to go if we wanted it to be a reciprocal function, Travis? I'm looking at number 3 here. I'm given 2 blanks and I have options of 5 and 3x. I'm sorry? I can't hear you. Below the 6. Very good. The x would have to go down there for it to be a reciprocal, which means the +5, add 5, up 5 would go there. All right? How about number 4, Daniel? What do you think? Where would the 7 and where would the x have to go? You don't have to yet. Good. We're trying to make it a reciprocal function. Good. Does this one go up or down at all, Matthew? Number 4. Does it go up or down at all? No, because there's nothing added or subtracted at the end, right? All right. How about number 5? What do you think, Kimberly? What, the x plus 1 goes somewhere and the 2 goes somewhere. What do you think? Good. Any transformations happening here, Nate, in number 5? Up, down, left, or right? Any shifts? There's nothing being added at the end, right? But what about that plus 1? It's going to go left how many? Perfect. Very good. And the last one we know happens here. There are 2 different shifts happening in this particular function. Okay, Patrick, can you tell me one of them? Up, down, left, and right, and by how many? Right 8. Perfect. Carolina, give me the other one. Perfect. You guys remember. Yay. Yeah, absolutely. Okay. So here's where we have several different pictures. Okay. They are curves, and they are guided by these things called asymptotes. Okay. So, well, the asymptote. Well, I'm going to show you what to graph in just a minute. Okay. I'm looking at this particular function. From what you know right now, without having to use your calculator, could you pick which one of those 2 graphs it should be? The first one, the middle one, or the last one, Natalia? What do you think? If you had to make a guess from what we've graphed so far, could you estimate, or could you pick the one that would work? What shapes have we done so far? Have we graphed anything like the middle yet? So could we probably eliminate that one? Okay, we will next class look at something like that, but that's not what we're doing right now. Travis, you want to guess? It is the first one. Okay, this is, and you should, let's go ahead and try it on the calculator. Plug it in. 12 divided by x. See if you don't get that shape. Tell me what you think. What is 12 divided by x on the graph? Does it match with the first graph? What do you think I would have to do to get the second graph? I'm sorry, the second one, the last one. I'd have to have a negative in there. The negative, if you remember, flips it, doesn't it? So when I flip it, I do get this one. Okay, so when we have a negative, the direction's going to be flipped. Awesome. Good, good, good. So let's try one, and we're going to graph ourselves here. Oh, these are the notes. I'm sorry. But I think you know this stuff already because we've already talked about shifting and stretching and that kind of thing. So this is just the notes of that. Basically, if we have this number, the number up there, you don't have to write it down, but just kind of think about it. If I have a 2, a 3, a 4, a 5, doesn't it kind of stretch it? We've already talked about that. What if I had a number down here at the bottom? Doesn't that move it left or right? Already talked about that. What if I had a number here? I'm adding or subtracting. Doesn't that go up or down? You know, when you're adding at the end or subtracting at the end, that goes up or down. We already know that. We've already talked about it. But let's try one. This is one you're going to graph. Okay? So this is the one that you have your graph paper for. Okay? You have your graph paper for. Make your x and y axes. And let's talk about what we would do to graph it. So make an x and y axis on your paper. Write your function down. This is the one we're going to be graphing together. I want you to do it on graph paper. So use your ruler. Make your axes. As you are creating your graph, can you tell me what in the function is happening from the parent, from that reciprocal family, that 1 over x? What do the 2 and the negative 3? Left 2. Very good. I know I'm going to go left 2. What about the negative 3? What is it going to tell me to do? No. Down 3. left 2 and down 3 are where my asymptotes move. So when you are graphing your function, go ahead and make a dotted line, because remember we use dotted lines for my asymptotes, down 3. So you're going to, not do our graph yet, but I literally want you to, hang on, I guess I have to, okay. So I am going to go down 3. So that simply means down here at -3, I'm going to make an asymptote, because it told me I went down 3. Okay? That left 2 means those are my new asymptotes at 2. I'm sorry, left 2. Remember, it started at 0, 0, right? The original function, the parent, had x equals 0 and y equals 0. It was the axis. So left 2, and I'm going to make a new asymptote, a new dotted line. At this point, I can kind of just draw in the shape. So I'm going to kind of make a sketch. When I am looking for a graph that you are creating, I'm going to be looking for the dotted lines, the guidelines of my graph, and then the shape. Now, we're going to estimate it. It's going to look something along these lines. Remember that this is the direction. I could go ahead and check some points on my table to be more exact if I wanted to. Probably not a bad idea. So let's plug that in real quick. What is it? X plus 2 plus 3. Oh my gosh, 3. All right, so if we go here, we'll just clear all these bad boys out. So I'm going to make 1 over x plus 2 minus 3. Your calculator will not show the asymptotes. Okay? They don't show the guidelines. So it's up to you to be able to put them on your graph. Okay? So I'm going to be looking for them with a dotted line. The calculator will not show them. But doesn't it show it moving left and down? Can you visualize that part? You know what else it will do? It will show where the vertical asymptote is. If I go to the table, notice at -2, what do you see? Why? Huh? It doesn't ever hit that value. What is an asymptote? It's an imaginary invisible line that the graph gets really close to it, but it never touches it. There's no way that I can have a graph on this particular, the graph never touches -2. So the asymptotes will show up as errors in your table. Okay? Now, it does. I really want you to be pretty particular about the asymptotes and where they are. Okay? Pretty particular. Let's try one more. Okay? One more graph here. Whoa. Erase all of it, just this part. Why does it keep doing that? All right, we're going to leave it. You just know that's next. I'm not sure why it keeps wanting to erase. Graph this one. Notice where the negative is. So all the things I'm going to highlight here, all are going to affect the graph. I'm going to highlight the 2 also because it makes it kind of spread out a little bit. Okay? So we're going to be graphing this. Make sure you graph where the asymptotes are. And then the negative affects where the graph goes. You can use your calculator to help you, but I need the guidelines essentially there. So one more graph. Let's put this on our paper. So it looks like as I walked around, quite a few of you had this correct, which is great. We should know from the function here, from the equation, that we're going right 3 and up 2. So that's where my asymptotes are going to be. Right 3 and up 2. The negative implies that I have flipped, so we're going to use my dotted lines as my guidelines, and it looks something along those lines. Again, we could be more exact and go to my table and plot exact points. I'm just creating a sketch here using my asymptotes as guidelines. What does the 2 in the numerator do? It just makes it kind of further away from that center, right? Kind of like plots it further away. All right, let's try another one, a different type of problem, okay? This is going to be one like you're going to see on your homework. So if I had this function, it's a version of my parent reciprocal function, but what's different about it, Zakira? What's different about that than the parent? What number is in there that wasn't in the parent? Wow, Zakira, you're like a ventriloquist over here. It is a 2. You're right, okay? But we're going to treat that, we'll just leave the 2 in our answer. What if I told you that I wanted you to have the asymptotes like this? These are now asymptotes. These are my given asymptotes. I want you to write an equation using that as my parent graph. What does x equals 0 look like in terms of an asymptote? Does that mean it's gone right so many, down so many, left so many? What kind of an equation is x equals 0? Is it a vertical line or a horizontal line? Think back to Algebra 1. X equals 0. What kind of a line is that? It's a vertical line. It's at 0, which means with my graph, x equals 0 is just that line. It has not moved left or right. Okay? What about y equals 3? What does that tell you? It's a horizontal line, and it's going up 3. So we'll treat that as a 3. So how would I write my equation? Y equals 2 over x. Where does the 3 go? Does it go down in the denominator, or does it go at the end? It goes at the end, because I've gone up 3. Is there anything in the denominator with the x? No. If I change this and said it was, let's say, -1, that would mean that this graph went left 1. Do you agree with that? Left 1. Where does left 1 go in my equation? X plus 1. So if you're given the asymptotes, you should be able to go from the asymptotes to the equation and backwards from the equation to the asymptotes. So you should be able to go back and forth. Okay? You want to try one more with this? I think we should. What would the equation be if you had this as my parent still, and I had the asymptotes x equals 4 and y equals -2? What would my equation be this time? What does x equal 4 tell me? What's -4, and where does it go? Does it go down in the denominator with x, or does it go at the end of the equation? It goes in the denominator. It's a vertical asymptote. So if I'm thinking of graphing that, it means out here at 4, I have a vertical asymptote. It has moved right 4. So where does my graph become? Where does the 4 go? Or is it a -4? So with the x, is it x plus 4 down here or x minus 4 down there? Minus, because it's what you opposite of what you think. What does that -2 do? Going up 2. So my new asymptotes look like this. So -2 at the end. Okay? Oh, thank you, Oshumi. You're exactly right. It would go down 2. I drew it wrong. Sorry about that. You're exactly right. You sure do. I'll get one for you in just a minute, okay?
You always getting something.
It's because he's good. He's paying attention, and he's right. Because he caught me being a dum-dum. All right, last type. Then catch me in a mistake. Let's go. Let's go. You might do it. You don't want one. All right. The last one, the asymptotes. Oh, you mean if I was going to graph the whole thing? There's no negative, so it would just be like this. The asymptotes went right 4, down 2, and then you use those as your guidelines. If there was a negative up here, then they would go in the different parts. Okay? All right, last one. Why does this look different to you? Because what? It doesn't have y equals. I got to get it by itself. I don't do anything with the x yet. Subtract 4 first.
Boy, let me finish what I was saying.
Now what?
Now you got to divide it.
Good.
Yeah.
Now does it look like something we could graph?
Yeah.
What are my asymptotes going to be? Have I gone up, down, left, or right? What shifts do I have?
Isn't it plus one, right? At the bottom.
Nope. I don't shift anything. I don't. The -4 has up there in the numerator does not do a shift. If you had a -4 out here like this, it would mean down 4. That's what the negative does. Okay, the negative flips the direction. So this graph, where are my asymptotes? They're just the origin, right? There's x equals 0, y equals 0. So they are literally here and here. And then the negative does this. It flips where I go. The 4 just means it's kind of moved out away from the origin a little bit. Okay? All right. So your homework is just 9 problems, much like what you have done today here. I did provide you with the graph, so you don't have to worry about making your own graphs. How did I set you up? Nope, no time today. Okay. So this graphing rational functions is going to be your homework.